Hi, now the examples for continuous varying annuities, the 4K. So the example 1, so continuous annuity pays at the rate of $t at time t for n years. So assume I is constant and calculate the present value. So now the function is t. So in general, we have the f of t, but the this may be the one of the simplest case for this annuity. So we have the t, and the t is from 1 to n. And the payment rate is t, so it increases by a straight line. So this is the y is equal to t. And this is payment rate. So if we have n here, maybe I would say it's n here, then the payment rate is n here. Okay, so think about just the small amount, the t to delta t, t to t plus delta t. Then we think about the present value of this cash flow. So present value of this cash flow is equal to, okay, so this is, okay, so t, and this, the width is delta t. So this area is the t times delta t. So the present value is the v to the power t times delta t. So this is the delta t times delta t. So that means the present value is equal to integral the 0 to n, the t times the vt dt. So we have to do integration by parts. So in general, remember that the integral of f times g prime is equal to f times g minus integral of f prime times g. So that means if we have f of t is equal to t, then we just have t here. And then that we differentiate this, the v to the t's power. So that is the v to the power n over basically v to the power t over the log of v. Then we plug in n and 0. Then minus integral the f prime of g. So f prime, so if we differentiate t, that becomes 1. So 1 times, again, the g. So g is the integral of g prime, so antiderivative of g prime. So this is, again, the v to the t's power and log of v. Oh, sorry. So yeah, so these are the antiderivative of v of t, v to the t's power. Then dt. So now we calculate this. So we plug in n and 0. If we plug in 0, the t becomes 0. So we only have the first term. So n times the v to the n's power over the log of v. Okay, then next one. So negative, so v to the t's power over the square of log of v. And we plug in n and 0 here. So yeah. So we use the notation delta. So delta is equal to the log of 1 plus I. So that is negative of log of v. So if we use this delta, okay, so we put delta here, and log of v is negative delta. So that we have the negative of the n times v to the n's power. So the negative of the v to the n's power. And here that we have the square of log of v, so that is the delta square. So we can say that that is okay. This and okay, if you plug in n and 0, v to the n's power minus 1, and we have negative sign here, so 1 minus v to the n's power. And this is actually the present value of continuous annuity a bar and right angle n, right? So we have seen in the case 1 in the previous video, then minus n times the v to the n's power over delta. So it becomes a simpler form. So if we recall the continuous annuity, so this is the present value of continuous annuity. Then we have just a little modified formula, a bar right angle n minus n times v to the n over delta. Okay, so this is the example 1. So example 2, this is more concrete example. So in some sense, it's easier, but in terms of calculation, it's a little bit more complicated. And it is actually not difficult if we understood the example 1. So example 2, so our 10-year continuous annuity pays at the rate of 100 plus 5t at time t. And assume that the interest rate is 4%, annual effective rate is 4%. Calculate the present value. So the situation is similar to the last question, but the payment rate is 100 plus 5t. So that means that at time 0, the rate is $100, but it becomes larger over time. So maybe this is too much. So actually the t is equal to 0, 100, but the t is equal to 10. That becomes only 150. So maybe I would say like this. So originally 100 here and here 150. So the payment rate changes from 100 to 150 over 10 years. Yeah, so if the constant at 100, then payment rate is, so the total payment is 10 times 100, so $1,000. But here, the payment rate is between 100 and 150. So that becomes actually the area of the trapezoid. So that is between 1,000 and 1,500, actually the midpoint of this, so 1,250. So, but we want to calculate the present value of this cash flow. So, yeah. So the present value, so always that we think about the very small amount, small area from t to t plus delta t, then we can see that this area is equal to ft times delta t. So this ft is 100 plus 5t. So that means the PV is integral, the 0 to 10, this ft times the v to the t's power. So 100 plus 5t times the v to the t's power delta t. So in general, so this formula was f of t times the v to the t's power times dt. So now we have to integrate this function, but we have a shortcut if we have the previous example. Previous example that we have calculated the integral of t vt dt. So that part is the same as this. So we can just decompose this into two parts. So the first one is the integral 0 to 10, 100 times vt dt, and the second part is 0 to 10, maybe yeah, I would put 100 first. Okay, so 100 times 0 to 10, and here 5 times 0 to 10, t v to the t's power dt. And from example 1, this becomes a bar 10 minus n times the v to the 10th power divided by delta, so that is the log of 1 plus I by example 1. So this is what, and also that we can see that this quantity, this is the continuous annuity. So this is by case 1 is equal to the a n right a bar right angle 10, a bar right angle 10. So this is case 1. So now we can calculate this. So this is equal to 100 times 1 minus v to the power n, maybe one more step, maybe the 1 minus v to the power n over delta, and plus the 5 times this 1 v to the power 10. So 10. So yeah, this is the yeah. So a right angle 10 bar minus n is 10, n is 10. So this is 10 times the v to the power 10 over log of I. Yeah, log of I is also delta, so delta. So yeah, you can see that the delta is equal to log of 1 plus 1.04, and v is equal to 1 over 1.04. So you can get this as 100 times 1 minus 1.04 to the power negative 10 over log of 1.04 plus 5 times the same quantity. So yeah, we have the same quantity as this. So this and this are the same. Then minus 10 times 1.04 to the power negative 10 over log of 1.04. Then this is equal to, the first term is 827.21, and the second term is the 5 times 38.665. So about 200, a little less than 200. And this is actually equal to $1,020.53. Yeah, so now that we got the answer, 1,020. Yeah, so the point is that this is a linear function of t. So we have a little complicated function here, but this is a linear function of t. So 100, this is the usual, the continuous annuity with constant payment. And 5t, so this is just what we covered in the previous example. So just if we decompose it, then we can calculate without dealing with integrals. So integral immediately comes these formulas. And what's the total payment amount? So the payment amount is the area. So total payment amount is the area under the graph. The sorry, this is area. So not R. This is area under the graph. So this is 1,250. So you can see that the area, this is the trapezoid with the base 100 and the 150, and the height is 10. So this area is equal to 100 plus 150 over 2 times 10 times 10. So this is equal to 1,250. So this is the total payment. But the present value should have some discount, and the interest rate is 4%. So actually it's smaller, and $1,020.53.